Algebra II 6.2b, add or subtract rationals with unlike denominators. Now we did like denominators in 6.2a, and if you missed that one, I don't want you to get confused. You can click on this video's description and watch that one first. When we add or subtract rational expressions with different denominators that are not additive inverses of each other, we must first find the LCD, that least common denominator. The LCD is the least common multiple of the denominators. It's the LCM. Now, to find that LCM of two or more algebraic expressions, we first factor each expression. Then we use each factor the greatest number of times it occurs in any of the factorizations. So we have three expressions here, and to find the least common multiple, we factor them. We can factor the first one, this x squared minus y squared, as an x plus y, x minus y. This one factors as x plus y times x squared minus xy plus y. And this one factors as an x plus y, x plus y. And we can see that our least common multiple are all the ones in orange. Here's our least common multiple. That's a lot, isn't it? So that's what we're going to talk about in this video. When finding LCMs, the least common multiples, we find factors that are additive inverses. We don't use them both. Okay? So take a look at this. If we've got an a minus b, if this is in one factorization and b minus a happens in another, we don't use both of them because b minus a is equal to a negative a minus b. Now, if you don't understand that, let's plug some numbers in to see if that makes sense. So let's say a is a 7 and b is a 2, and we've got 7 minus 2. So that means we have 7 minus 2 in parentheses like this one, and 2 minus 7 like this one, right? Because it's flipped around. Well, 7 minus 2 is a 5, isn't it? And if we plug it in this way as a negative 2 minus 7, we get negative 2. And these two negatives make a positive, don't they? So we get negative 2 plus 7. So that equals 5. So they both equal the same thing when we do this. See that? So that's why we only use one of them. So if we find least common multiples and the factors are additive inverses, we're just going to use one of them, okay? So take a look at this. We're going to add. We've got 7a over 8 plus 5b over 12a. First, we have to find that least common denominator. So we're going to do the multiples here. 8 is a 2 times 2 times 2. 12a is a 2 times 2 times 3 times a. So that lowest common denominator, that least common denominator, is 2 to the third power times 3 times a. See? When you put them all together, which would be 2 times 2 times 2 is an 8, times 3 is 24, times a is 24a. See? Now we multiply each expression by an expression equivalent to 1. We talked about that in the previous video, didn't we? In the 6.1 videos. So we choose a ratio equivalent to 1 that'll give us the least common denominator, 24a. To make this a 24a, we have to multiply it by a 3a. And the numerator gets jealous. It has to be multiplied by a 3a also. So there's our ratio of 1. That's going to give us a 21a squared over a 24a. Now we're adding this one. See, this is the second one. What can we multiply this 12a by to get a 24a? We can multiply it by 2. 5b gets jealous. It wants to be multiplied by 2. That's our ratio of 1, and we get 10b over 24a. Now we just rewrite it over a common denominator. We've got 21a squared plus 10b over 24a. See? That's going to get a little more difficult, so try to stay with me, okay? If you lose me, then just rewatch the video, okay? Because this is going to get pretty extensive here. All right, so we want to add this expression to this expression to this expression. So the first thing we have to do is factor the denominators and find that least common denominator. This is 2 times x, isn't it? This factors out as a x minus 1, x plus 1, and that's just x plus 1, isn't it? So our least common denominator is going to be a 2x times x minus 1, x plus 1. See? We got an x plus 1 again, so we don't use it. So we got a 2x times x minus 1, x plus 1. That's going to be our denominator. Now we multiply by a ratio of 1 to get the least common multiple in each denominator. We want them all to have the same denominator, this, as the denominator, okay? And we add and simplify, and we leave the result in a factored form. So if we want every single one of these terms to have this for a denominator, what does this 2x need to be multiplied by to get to be this? Well, it needs to be multiplied by an x minus 1, x plus 1, doesn't it? And we have to multiply the 1 numerator by the same thing. That's our ratio of 1, okay? That's going to give us this right here, okay? What does this guy need to be multiplied by to be a 2x, x minus 1, x plus 1? He needs to be multiplied by a 2x. So the numerator has to be multiplied by 2x. That's going to give us 10x squared over our denominator. What does this x plus 1 need to be multiplied by in order to look like this? It needs to be multiplied by a 2x times x minus 1. So the numerator has to be multiplied by the same thing, as a ratio of 1. That gives us 6x times x minus 1 over our denominator. Now we're on this line, and we have to FOIL or distribute in the numerators. So we're going to FOIL this guy, and we're going to get x squared minus 1 over our denominator. This guy's just going to drop down because he's fine, and then this needs to be distributed. So we get 6x squared minus 6x. Okay, so that's this guy right here. Now we can write it over one fraction bar and add all like terms. So we got x squared, we got 6x squared, we got 10x squared, okay? And when we combine the like terms, we get 17x squared minus 6x minus 1. See that? And it's over our denominator. Let's try a subtraction one. We're going to subtract this expression from this one. So first we're going to factor the denominators to find that least common denominator. This is a y minus 6 times y minus 1 for this denominator. This is a y minus 6 times y plus 1. So our least common denominator is going to be a combination of these. Now because we have a y minus 6 and a y minus 6, we only use one of them. See? Then we get the y minus 1, y plus 1. So that's going to be our denominator. All right? So what does this guy need to be multiplied by in order to look like that? The only thing we're missing is the y plus 1. So we multiply it to the numerator and denominator as a ratio of 1. And we go straight across, don't we? Now we've got this guy. What does he need to have a denominator that looks like that? He needs to be multiplied by a y minus 1. So we do the same thing for the numerator. Now we can write it over one fraction bar, and we've got this 2y plus 1 times y plus 1 minus y plus 3 times y minus 1. See that? We combined them. And they're over the denominator we need. Now we need to subtract. We need to subtract. And after multiplying these and foiling, okay, we get 2y squared plus 3y plus 1 minus y squared plus 2y minus 3. Now, if we stacked these and subtracted them, we'd see we get y squared plus a y plus a 4. Because remember, we're subtracting. So 2y squared take away y squared is just 1y squared, isn't it? And if we have a positive 3y and we subtract a 2y, that's just going to give us a 1y, isn't it? And if we have a 1 and we subtract a negative 3, we add the opposite. It's going to give us a positive 4. So now that's our numerator, and it's over our denominator. See? I know this can be confusing. It's just taking it one little step at a time and rewatching the video if you have to, okay? If you don't understand factoring, you've gone a little bit too far in these videos, and you need to go back and understand factoring, okay? Now take a look at this one. This one's got an addition here, but a subtraction sign here. Well, we can still calculate this. Do the same thing. We're going to factor the denominators to find the least common denominator. This is an x minus 2, x plus 2. And that is going to be our least common denominator that we need to have as the denominator for all of them. this guy is in the wrong order. It says 2 minus x, and if you saw the previous video, you know we can flip it around. If we multiply the numerator and denominator by a -1 over a -1, what's going to happen is it's going to change that to a -5 over a -2 plus x, and we can put this -2 behind the x and have x minus 2, and then we have a -5 for a numerator, okay? So now we're going to use this as our second expression, okay? So here's this guy with our new denominator, all right? Our least common denominator. And we've got this guy, the -5 over x minus 2. Now what does this denominator need to be multiplied by to look like that one, to be our least common denominator? It needs to be multiplied by an x plus 2. Well, numerator gets jealous and he wants to be multiplied by x plus 2 also. All right? That's going to have to be distributed in, isn't it? And then on this side, what does this denominator need to look like that? It needs to be multiplied by an x minus 2. So we have to do the same thing for the numerator. Now we've got 2x minus 5 times this x plus 2 minus an x minus 2. When we distribute this, we get 2x minus 5x minus 10 minus x plus 2 over our denominator. Okay? Now we can combine these like terms. See all the red terms that are like terms? If you have 2x and you take away 5x, you have a -3x, don't you? And if you take one more away, you have a -4x, don't you? So there's our -4x right there. When you have a -10 and you add 2, you get a -8. So now we're right here, and it's over the denominator we need. See that? And we need to factor this guy. And it can be factored as a -4 times x plus 2. This numerator right here, it becomes a -4 times x plus 2. And if you look at our denominator, we have an x plus 2 down there. And if you've seen my previous videos, you know that it's the same thing as a 1, because the numerator and denominator are the same, and we can eliminate it, can't we? That leaves us with a -4 over x minus 2. See? Now, if you're really, really confused, I want you to go back several videos and start watching again, okay? You might even have to go back into chapter 5, but at least go to 6.1a and start watching from there, okay? Because everything is explained in every single one of my videos, all right? So our next video, 6.2c, is going to be about graphing rational functions. I'm going to add this video to the Algebra 2 playlist. This is your link to help you in confusion. If you go to this Algebra 2 playlist for JoAnn School, you're going to see all the previous videos, all right? But I'm also going to put in links from Algebra 1 that can help you, because we talked about a lot of this in Algebra 1, and there's going to be 5 videos from Algebra 1 in here to help you, okay? All you have to do is go to the description of this video and click on the link, all right? I hope it was helpful. I hope it wasn't too confusing. I know there's a lot of information. I hope you're doing well. And don't forget to hit the like button if I helped you, and I'll see you next video. Bye.